What we're going to look at today is the logarithm function. Okay? We use the logarithm function with our exponential function because they are inverses of each other. All right? So we have specific reasons that we use the logarithm. Basically, it is to, when you have an exponential function, your x is the exponent, right? And sometimes we can't reach it and find that value. And that's why we use our logarithms. Okay? So I'm going to take this right here. This is your exponential function, your b to the x equals a. Okay? I'm going to take that and I'm going to rewrite it as a log. Okay? So right here, my base is my b, so that's going to be down here, and we call that the base. And the thing about a log, the log is really just the exponent. The log is actually the exponent. So right here on the equal sign, it equals x. Your log equals the exponent. Okay? The log is the exponent. Okay? And then the a will be in the parentheses, and we call that the argument. So the way we read this is we say log base, in this case our base is the b, log base b of a equals x. In other words, what is the power of x? What do you raise the power of b to get your answer, your argument? Okay? That's how we say it. And the whole reason we have the logs is so you notice over here, the x is the only one on the right side of the equation. So we use logs to isolate the x, or the power. And once we do this, we have many, many uses for our log function. All right, so let's take a look at some examples of rewriting our exponential equation into that log form. I'm going to come over here. I have 7 to the second power equals 49. So I'm going to write my log. My base in this case is the 7. My answer was the 49. And what was the exponent? The exponent was a 2. So your log is the exponent. I'll do another one. Let's take a look at b. We have 3 to the 5th power equals 243. So I write the word log. Then I write the base. In this case, the base is 3. I got a 243. And my exponent was a 5. Okay? So what is this? This is 3 to the 5th power gives me a 243. Let me do one more. We have 6 to the negative 2 power equals 1 over 36. So again, I'm going to write the log. My base is the 6. My answer was the 136 equal to my power, which was a negative 2. And let me remind you, when we have negative exponents, remember what that means? That means you drop your number into the denominator. Okay, so we will have these negatives as we work through these. Okay, and I want to come over to number H, or letter H, real quick. Letter H is log base 2 of 64 equal to x. So we're going to go the opposite direction. We're going to turn that back into an exponential. When you go back to exponential, you always start with the base. So when I'm looking at this, I see the base is 2. So I do 2. And my power In this case, it's the x equal to that argument, which is a 64. All right, I'm going to stop the recording. I want you to do D, E, F, G, I, and J. And when you're done, turn the video back on. All right, go back and check your answers. D, log base 9 of 27 is 1.5. E, log base 4 of x equals 9. F, log base 2 of 20 equals x. G, log base 8 of 32 equals x. I, x squared equals 64. And you could actually find that. You know what you can square to get you 64. And then your 64 squared equals x. And you could find that x as well by squaring your 64. And one more thing I want to show you in this video is common logs. You have a button on your calculator that is a log button. That log button is based on common logs, and common logs use what we have is a base of 10. All right? And logs that have base 10, when you see 95% of the time, if you see something, a log of base 10, they will not show the base, okay? Remember how we had square roots and that index of 2, they don't show us, right? We just assume it. So if you see a log that doesn't have a base, you will automatically assume it is base 10. These are the logs that you can put into the calculator. So if we come down here and look at K, I have log and then 100 equals 2. I don't see any base, so I automatically assume that it is a base of 10. So until you get the hang of it, you can write that in. And then now, when I go over and write it as exponential, I'm going to have 10 as my base raised to the power of 2, and that will equal my 100. And then below that, we've got log x equals -3. Again, you're going to assume that that is a base 10. And then you can put it back in exponential form. So you would have 10 raised to the -3 power equal to x. So here's a case where you had the log, and it's beneficial for you to rewrite it back into the exponential form, because now you can figure out what x is. Okay? So it works, they complement each other, right? Okay. I'm going to stop the video and let you do M and N. All right, so take a look at your M and N. M becomes 10 raised to the 4th power to equal 10,000, and N is 10 to the x power, which would equal the 1/10. All right, I want you to bring this to your notes to class, and we will look at these and do some problems when you get to class.